Page 448, number 37. Part A. Find the distance from the center of the pitcher's rubber to the far corner of the first base. So from the diagram that was given in the book, you can see that we're looking at triangle ABC, and we're trying to find the length of side C. So if you notice, we're given side angle side, 40 feet from the pitcher's rubber to home plate, a 45-degree angle at home plate, and then 60 feet from home plate to first base. So that's side angle side. So we're going to use the law of cosines. And so we're going to use that C squared is going to equal A squared plus B squared minus 2 times AB times the cosine of side C. So filling everything in, we get 40 squared plus 60 squared minus 2 times 40 times 60 times the cosine of 45 degrees. So C squared, I'm going to put that in my calculator, is 1,805.9. So then C would be the square root of that, and I get 42.5 feet. So that's the distance from the pitcher's rubber to the far corner of first base. Then, in part B, we're asked to find the distance from the center of the pitcher's rubber to the far corner of second base. So now what we're looking for is this section right here. So what we want to do is form a different triangle where we have 60 here. This is a right angle right here. And we also know that the distance between the bases has to be the same. So this is 60 feet. So we have an isosceles right triangle. So the hypotenuse of this triangle is going to be 60 times the square root of 2. So that's clear from here the whole way up. So here's our right triangle right there. Okay, and then using that, we can just figure out that the distance is going to be 60 times the square root of 2 minus the distance we already know from home plate to the pitcher's mound, which is 40 feet. So we can just leave our answer like that if we want an exact answer, but since we're dealing with a specific item, a baseball field, we'll put that in our calculator and round it, and we get 44.9 feet. Then finally, this should say part C. Part C asks us to find the measure of angle B in ABC. So we're back to our original triangle, and we can find the measure of B using the law of cosines. So we're going to have cosine of B is going to equal A squared plus C squared minus B squared, all divided by 2 times A times side C. So cosine of B is going to equal 40 squared plus 42.5 squared, which we found in part A, minus 60 squared. So you can see that. Move this over a little. There we go. And that's all divided by 2 times 40 times 42.5. So then B is going to be the arc cosine or inverse cosine of that. And again, like we did in our other examples, I will put this entire thing in my calculator so that I have the smallest possible rounding. So I have the most accurate answer. Okay, finish copying this out. and I get that angle B is 93.3 degrees.